In this video, let us talk about classification technique called K nearest neighbors, better known as KNN. So let's say we have a data set with two categories already present. So we have identified two categories, category 1 on the left, which is represented by a green card, and category 2 on the right, which is represented by a blue card. To keep things simple, we'll focus on just two variables or columns in our data set. So that is x1 and x2. To group this, so basically these are the dependent variables and these are the independent variables. To group the data into two categories, let us consider a situation where we have a data consisting of two categories, green and blue. Now suppose we add a new data point to this data set and we need to decide whether it should be classified as green data point or blue data point. So in other words, we need to determine which category it belongs to. So how can we go about this? And that's where the nearest neighbors algorithm comes in to assist us. By performing this algorithm, we'll be able to identify whether the point is blue or green. So in this case, the point turned out to be blue. So how does the K nearest neighbors algorithm work and how did it do that? So we are planning to create a step-by-step guide for the KNN algorithm. So once the guide is ready, we will manually perform the algorithm to test it. The algorithm is very simple and the first step is to select the number of neighbors in the algorithm. So we need to determine k is equal to 1, 2, 3, 4, 5 or a different number. The most commonly used default value is k is equal to 5. The next step is to select the k nearest neighbors of the new data point based on Euclidean distance. However, you have the option to use other distances such as Manhattan distance or any other distance that you prefer. Nevertheless, in most cases, it is recommended to stick to Euclidean distance. So after selecting the k nearest neighbors, the next step is to determine the number of data points that fall into each category. So this involves counting the number of data points that belongs to each category. Even if there are more than two categories in the dataset, so simply calculate the number of data points that falls into each category. And then you need to assign the new data point to the category with the most neighbors. So this is why it is called K nearest neighbors. So now that your model is complete, we'll use a simple algorithm to predict the future outcomes. So let us reinforce this knowledge with a manual exercise. So let's move on to that. So as we see, a new data points has been added to our scatter plot. Now we need to determine the nearest neighbors of this new data point. So let us have a look at the Euclidean distance that we are going to use. So Euclidean distance is a measure of the distance between the 2 points in a 2 or 3 dimensional space, and it is based on the Pythagorean theorem and is calculated as the square root of the sum of the square difference between the coordinates of 2 points. So this distance matrix is commonly used in various fields such as machine learning, computer vision, signal processing to compare the similarities and dissimilarities between the two data points. So this is the formula to calculate the Euclidean distance between the point P1 and P2. Now, how do we identify the 5 closest neighbors on your data point? Well, we can look at the distances and determine which ones are the closest. The closest ones would be the first on the list, followed by the second, third, fourth, and fifth closest. So we have outlined those for better clarity. So as we have completed step 2 of the KNN algorithm, so moving on to the step 3, we need to count the number of data points in each category. So in category 1, we have 2 neighbors over here, and in category 2 we have 3 neighbors. So the step 4 involves assigning a new data point to the category that has the highest number of neighbors. So in this case we need to assign it to the blue category. So this is a simple process that completes the classification of a new point and your model is now ready to use. This is a straightforward algorithm and one of the simplest in machine learning for classification. Also, we have taken 2 columns for simplicity, but there can be multiple columns or in machine learning terms, independent variables. So the computer will perform this calculation for us. So this was it from the K nearest neighbors, and in the upcoming video, we'll do some practical assignment as well. So stay tuned for that and subscribe to my channel if you have not yet done that, and I will see you in the next video. Until then, keep thinking data science.